Hello everyone, today we are going to work on this fish school of fish Niagara system. So here is the final demonstration of what we are going to implement today. So as you can see, these fish have something like an animation, but since this is a Niagara system, we are not actually using skeletal meshes. These are just static meshes, but the swimming animation is implemented through the material with world position offsets. So that's how we get this ripple effect in the fish body. So let's see how to implement this today. And if I show you a single fish static mesh, this is a static mesh. This is how the material works. As I move it, let me disable. When I move it, you can see this fish get this swimming like behavior in its body using world position offset. Right, so let's see how to do these things today. Okay, so this is Unreal Engine 5. Let me create a new project. Fish. We don't need starter content or anything. I select the blank template and create. Right, so this is what I got. Actually, let's switch to a basic map. Right, now I'll create a new folder FX and another folder meshes. Inside the mesh, first I'll create another folder called fish. So I have a fish model. Let me import it. This is not a skeletal mesh, it's a static mesh. And yeah, everything seems fine. Let me import. So this actually pretty big, so maybe let's go to the import settings, and also forward should be this way. So under import settings transform, I'll set the uniform scale to 0.2 and -90 as the import rotation. Right, now the scale and everything seems fine. So I have two more textures. Let me import them too. A normal map and base color map. Let me create a material from using the fish mat. Let me drag and drop the normal map also. This should be enough for now. Let's use the fish material on this model. Fish mat. Okay. Alright, now we have our fish model. So the next step is, let's create the particle system. Here, new system from selected emitters. I'll choose this hanging particles, add and finish. I'll emit enriched fish. Okay, so this is what we got. And initialize particle lifetime 5 to 8 should be fine. here let me disable the sprite renderer and add a mesh renderer, and as the mesh I'll add fish. Okay, oh, how to save the map. I'll just call it fish map. So if I drag and drop, this is how it looks. The first look is like this, which is not good at all. So later on we are going to add some swimming animation as well on the static mesh based on the material, but first let's get the look of the flock or school of fish. So how do we get the movement? For that, let's add the point attraction force and the radius. I'll make it large so that any fish model from any point would be affected by this, and set the attraction strength to 100. Maybe a bit too much. 10. Right. So now the fish should be facing the movement direction. For that we can set the facing mode to velocity. Okay. Okay, now they are going to the same location. So, but if I move it, you can see they already get some flocking like behavior. So to change the location that they are trying to swim in over time, I'll change this point attraction force position to, let's say, add vector to position. As the first vector I'll use vertical position. Initial position. What's happening? Let's choose this particle position instead of that. Right. Now let's add an offset to this, and this offset should be changing over time. So let's multiply this vector by a float. Vector by float, and we'll add 1000, 500, 500. And this one, let's turn this into a sine. See, now they are trying to go to different location, but the phase is too fast. Period. So let me set the period to 10. Great. Okay, maybe we should reduce this. Okay, now they are Right, so now to get some more randomization, let me copy this node and add it again. So there will be two forces in action. I think that's how it works. Let's increase this value and I'll set the period to 50. So we will get some randomization. Let's set value also to something like 500. So now we have a completely random looking flock behavior. Right, now the next thing is, you can see the fish are being spawned in the air. So maybe let's try adding an initial velocity. Velocity in a random range vector. 500 plus 500 minus 500. 500. So they will have, right now it looks more like a natural fish flock. Okay, let me increase the spawn rate a bit. Right, now now this flock looks fine to me. Now let's work on the animation. For that, let's go to the fish material. So we just have this simple material with the normal map, and the base map is color map. So first, as the preview mesh, let's use this fish mesh. Great. Okay, now what I'm going to do is giving some world position offset based on the world position, pixel world position. So world position. So here let's consider let's do a component mask. Let's try with R only, and I want to give the world position offset in some direction. So let's create a vector, constant 3 vector. Let's first try with, now let's change it with both R and G, sorry, not R and G, G and B. That means we should be able to see a ripple effect in Z axis and Y axis both. So we can connect this to a sine to get a sine like curve value. Let's multiply it with this value and connect to the world position offset. See, now you already see some jagged look. So that is because the sine value is changing from -1 to +1 within a short range. So if I multiply this with the decimal value, like I don't know, 0.01, does that look fine? Let's apply, and we do have a fish here. Let's move this and see if we get any effect. Oh, we do. See. So do we see that in this fish? Not much. Why? It's not that obvious. So let's add another multiplier here. Let's promote this to a variable parameter. I'll call this triple magnitude and try a value like 10. Alright, now we see the effect, but they are bending too much, I think. Yeah, see? That's too much, definitely. Shall we scale up fish a bit? Mesh scale mode. Random uniform. Okay. Let's reduce this a bit more. 0.5, make it a half. Alright, now it looks alright, but the only problem is all of them are synchronizing the up and down movement, which kind of looks odd. See, so what if let me duplicate this and use B as well, and add this together and these two together, so we can have some change in value based on the Z location of the fish as well. Did I apply the material? Still we can see the pattern, common pattern. Alright, let's try let's use a particle color node. Yeah, we are actually not using the particle color. Let me just get rid of this, and then let's add the particle color into the sign, so that we can now give some random input to each instance of the fish by changing this color into random range linear color. Black and white. Right, now this should work. Okay, now that pattern is not there, see? Great. Okay, so I think that's enough. Let me delete this flow so we can clearly see fish. And I actually darken the level a bit using exposure. Let me ignore that. Alright. Let's try increasing the spawn rate to 500. Okay, so this is our fish, school of fish. And I'm going to stop this episode right here. One more thing. What if we change the spawning location of the fish as well? So, shape location. We have this function for the point attraction force. Let me copy this. And this is what we are using, shape location. Here, transform, offset mode, shape origin. Okay, let's paste. Right. Now they are not spawning in the same location. Great. So this is the final look. And thanks for watching. As always, project files will be available for the download in the Patreon page. Link could be in the description below. And if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye.